Hi, hello everyone. So this is Ravinder from Department of Computer Science and Engineering. Today in this session, we are going to discuss about implementation of binary classification with logistic regression. In the previous session, we discussed about classification problem, regression problem with examples. Now we'll build the binary classification and logistic regression. Now, first of all, let me explain about what is classification. Now, classification is a technique for determining which class the dependent belongs to based on one or more independent variables. Independent variable may be one or more, but the dependent variables must be categorized among different classes. The classification is used for predicting discrete responses, not continuous responses. Whereas in linear regression, that predict output in continuous nature. But this one, which predicts the output should be a discrete or categorical value. So classification means categorizing data and forming a groups based on that similarities. Yeah. After getting, the outputs, we may get many outputs, the target values as the output, right? So these outputs must be categorized, grouped based on similarities. So that, the classification works. In a data set, the independent variables or features play a vital role in order to categorize the output. Yeah, in this, whatever data set we are using, based on data set, based on output, we have to use the classification technique. Now, what are the categories of classification? For example, before classifying, categorizing the classification techniques, first of all, let me explain about its examples. Now, by using these classification techniques, we can categorize them, all the mails, whether mails or spam or not spam. That means the spam detection and churn prediction. And the third one is sentiment analysis. The fourth one is dark breed detection and so on. Now, coming to the categories of classification. So we can categorize the classification techniques broadly into two categories. Binary classification and, multi-class classification. Coming to the binary classification. In this binary classification, the output should be yes or no category, 0 or 1 category, male or female category, like that. Or spam or not spam, cat or dog, etc. So these all examples comes under what binary classification. That means we may have n number of independent variables. So based on these independent variables in data set, the whatever output we are getting, that output may be that output should be discrete in nature, the categorical in nature. So those outputs we can classify into a number of classes. That may be, as I told, the output may be 0 or 1, yes or no, male or female, right? And cat or dog, spam or not spam. And coming to the multi-class classification, second category, under classification technique of supervised learning algorithms. Now, in this, the classification of types of, crops, classification of types of music, etc. Now, here, that means that in binary classification, the output only consists of two categories, only two classes. But coming to the multi-class, the output more than two classes. If output or target value or dependent variable, if it comes under more than two classes, that classification comes under multi-class classification. Now, techniques in classification. The first one is logistic regression. Second one, K means K nearest neighbor, KNN algorithm. The third one, support vector machine learning algorithm. And the fourth one, naive Bayes algorithm. Now we'll discuss about logistic regression. Yeah, in that, as I told, there are two types are there, binary classification and multi-class classification. That means by using logistic regression, we can classify that output may be, two classes or output may be more than two classes. If output is only two classes, that is called as binary classification. If output more than two classes, then it can refer as what multi-class classification. Now coming to the binary classification. So logistic regression is kind of like a linear regression, but is used when the dependent variable is not a number, but something else, like true or false, yes or no, male, female, etc. It's called a regression, but it performs a classification based on the regression and it classifies the dependent variable into either of the classes. It's regression, but it performs classification based on, the logistic function. Now here, y is equal to fx, right? This one is what y is equal to fx. Now y is equal to fx, where y is what? Categorical output, right? Now here, so this categorical output maybe belongs to either class A or class B in binary classification, whereas in multi-class classification, there may be n number of outputs. Yeah. So this y is equal to f of x is a, it gives us the straight line. After getting this straight line, then what to do? Then we have to draw a straight line and we have to convert this straight line into sigmoid function. Sigmoid S-curve, S-shaped curve by using sigmoid activation function. Yes. So this line indicates what line of regression, and whereas the red color line is a S-shaped curve. So this curve will be formed by using sigmoid activation function. So here there may be threshold value will be there here. Based on threshold value, so we can categorize outputs into either of the classes, either class 1 or class 0 in binary classification. The values, the output above the threshold value is comes under what? Class 1, and the value or output below the threshold value is comes under what? Class 0. Now we can clip out the values below 0 and above 1 by using what? Sigmoid activation function. We can clip out that values above 1 and below the 0. So by using this sigmoid activation function, we can convert the straight line into sigmoid curve. Now, logistic regression is used for prediction of output, which is binary as stated above. Yes, as per binary classification, the logistic regression predicts output which is in binary format, like 0 or 1, male or female, and yes or no, like that. For example, if a credit card company builds a model to decide whether or not to issue a credit card to customer. So based on his history, his experiences, the company can build a model. That model can predict whether we can issue credit card to customer or not. So that is what a binary classification. We have to classify. We have to classify all the customers. Comes under issued category or not issued category. First, in logistic regression, first of all, we have to form a linear regression. So this linear regression is performed on the relationship between, variables, dependent variables and independent variables. First, we have to build that model. The threshold value for the classification line is assumed to be at 0.5. Yes. So this is very important in logistic regression, particularly binary classification. So based on this binary classification, though this threshold value plays very vital role. So based on this threshold value, we can categorize outputs into either of the classes. Yeah. So this formula belongs to linear regression. So y is equal to b0 plus b1x. So this output is what continuous nature, but according to the logistic regression, the output must be discrete or categorical value. So in order to get a discrete or a categorical value, we have to convert that output into what discrete values. How we can convert? How we can convert this continuous value into discrete? Yes, by using what segment activation function, we can convert that continuous nature output will be into discrete or categorical value. So logistic function is applied to the regression to get the probabilistic of it belongs to in either of the classes. Yes. After getting that continuous value, then we have to that value must be fed into the a segment activation function. That function will convert into a straight curve. Yes, this logistic function is applied to the regression to get the probabilities of it belongs to in either of the classes. That means here, after getting this mx plus c, now we have to give it to the sigmoid activation function. So this sigmoid activation function will give us output like this. So this is what a sigmoid activation function. Sigmoid activation function. So there is a formula already we discussed in previous session. The probability of z is equal to what y by 1 minus. Now this will give us what a probabilistic value once you apply log to this formula, will get output between 0 and 1. So this is what logistic regression will do. Will convert the continuous values into 0 and 1. Yes. So this is what a probability. Now whatever y we are getting is what? It is what? Continuous value. So by using this y, we can draw a straight line. Right. But what according to the logistic regression, particularly binary classification, we have to classify output. In order to classify output, that output must be in discrete nature or else what categorical. So in order to get discrete output, we have to apply sigmoid activation function like this. So this is what a sigmoid activation function p is equals 1 by 1 plus e power minus y. So this will give us what? Now, so this is what a brief introduction about logistic regression. And now we are going to build binary classification by using logistic regression. Now we'll discuss how to build a model which classify outputs either of the classes. Now here, first of all, we have to import all the libraries and packages. So we have to import, by using import keyword, we can import NumPy for numerical calculation purpose, scientific calculation purpose. We have to import this package with a short form NP, and for plotting purpose, we have to import matplot library. The function pyplot is there as a PLG, and we have to use pandas PD for scientific analysis purpose. We have to use PD. And here I'm using the incidence data set. First of all, we have to, download the incidence data set. I'll show here the incident data set. Yeah. So this one is what incidence data set here, which contains two columns, age and have incidence. Now, age 20, no incidence. 30, no incidence. 34, no incidence. 23, no incidence. And 40, the persons, the people, age 40 s have incidence, and 45 s, 39 no, 46 s, 50. Once you analyze all these data, see here, that means age below the 40 years, they won't apply for the insurance. The age above 40, they can, they may have, insurance. So this is what the data says. Now we can apply this data set to the logistic function technique, that to vendor classification, which classify the output into, have incidence or no incidence, yes or no category. Yes. Now let us build binary classification technique. Now by using this, the pandas, one method is there, read underscore CSV. So this read underscore CSV can read the CSV files. So already we have seen that the CSV file, his name is what, insurance.csv. And once, now if you want think about number of columns and rows, by using the print data underscore set shape, the entire data will be stored in, data set list. Now by using the shape method, we can find out number of columns and, rows. And, by using this data set head, we can, find out the number of heads and its corresponding values. So once, first of all, we have to run the all these packages. Yes. Now here, load the data set. Which data set we are using here? Insurance data set we are using for binary classification. Yes. Now let us run it. Control enter. Yes. Now here, this 40 and 2 indicates what? The 40 indicates what? Number of rows, and 2 indicates what? Number of columns. So once you go back and verify the insurance data set here, yes, there are 40 rows are available and 2 columns are there, age and insurance. Yeah. Now this one, the print data set head. So this head can display all the heads, that means all the columns of the data set, including its values. So it's extra, it will display the indexes 0, 1, 2, 3, 4 indexes, and age is one head and insurance in another head. So by using these two heads, the corresponding data, we can build a model by using logistic regression. Now here, the age 20, the person who have age 20 doesn't have insurance, and 30 also no insurance, 34 also no insurance, 23 and 40. The person who has the 40 years age, they can apply for insurance. But actually 40 rows are there, but the head can display only sample data up to 5. By default, it display only 5 rows. Now this one here, once you scatter Now if you want to plot all these data points, in the picture, now we can use the plot. Already we downloaded by using import method, the matplot library which contains pyplot. By using this pyplot method, we can plot all this data on the screen. Yeah. So the matplot which contains one method, scatter method. By using scatter method, we can plot all the values. Yeah. So here, this scatter method which contains, 4 parameters. The first parameter is, not only 4 parameters, we can give n number of inputs. Now here, as per our data set, insurance, which contains only 2 columns, age and insurance. Now I am passing here two columns as a parameters to the scattered function, right? Data set age and data set insurance. Now here marker, which indicates what, we can plot all this data by using plus symbol. Now if you want star symbol, whatever you want, you can mark it, right? The color we can change, right? I'm using here red color. Now if you want to use different colors, we can write there. Now once you run this code, yes, it can plot all the data points. Around the 40 data points are there, right? Now all these 40 data points will be plotted on this line. That means what here, once you look into all the data points, now here the persons who have an age below 40 years, that comes under no category. That means they won't apply for the insurance, right? Now this one, all these data points, around 30 plus data points are available. All these data points comes under what? S category. That means what, we can draw a sigmoid curve, right? So already we have seen that a sigmoid activation function. By using sigmoid activation function, we can draw this S-shaped curve. Now after downloading data set, insurance data set, then we have to split the data set into training set as well as testing set. We are going to you are going for building a model. Which model we are going to, we are building binary classification model, right? Now, so whatever data we have as a data set, we have to categorize, split the data, to whole data set into 2 categories: training data set as well as testing data set. So by using training data set, we can train the model. So after building the model, then the data set which doesn't known to the training model will give as an input to the model. By using that model, we can predict it. Yes. Now, we are categorizing the data. We are splitting. Yes. Here, I am splitting insurance data set, right, into training data set and testing data set. So by using this training data set, we can train the model. After training the model, then we can apply the testing data set. So for that purpose, I'm using here, I'm importing train underscore test underscore split method. So this method can split entire test data into x underscore train, x underscore test, and labels. So these are what? 2 labels. Y underscore train is a label for training data. Y underscore test, this label for what? Testing data. Right? Now here, I'm passing here different parameters here. One parameter is what? Age, and second parameter I'm using here, insurance. Because based on data we are going to classify, right? Now test size I'm using here 0.1. Now control enter. Yes, we split it, the entire data into, training data set as well as testing data sets. Well, now if you want to verify, that data sets, what are, out of 40 data points, now which one points are comes under training data set. If you want to verify x underscore train, we'll get, So these data points comes under, we can use for, training the model. Now, as well as if you want to verify the testing data, once you run this command, we'll get what, so these 4 values, only these 4 values for what testing purpose we can use. So when we can apply testing data after building the binary classification model, now if you want to test it, right, we can use it, this testing data. Now we have to download logistic regression, is a pre-implemented model. Logistic regression, we can use directly this model. So if you want build, we can build the model also, right? Now instead of building, we can, so I'm here using the ready-made model, logistic regression. So instead of implementing directly here, just I'm using ready-made logistic regression model, right? Once you run it, we imported this binary classification model. Now I'm going to create objects. Now I want to creating binary classification model object. So this object will be used for what? Training the model as well as testing purpose. The object name is what here? Model. MODEL is a object, is a variable. Logistic regression. Object has been created. Only empty object has been created. Now, after creating the empty object of the binary classification by using logistic regression, then we have to fit it. So by using that fit method, we can train the model. Which model we are going to train? Binary classification by using logistic, right? Now by using fit method, we can train the model. The what parameters we have to give? These parameters only. Which one? X train and Y train. So already we have seen that X train, which contains these many data points, right? Already we splitted the data set into 2 categories, training data set as well as testing data set. So these points are comes under training data set. Now I am going to building the model by using what? Training data set with its corresponding labels. Once you run this code, the model has been developed. The model has been built based on what? So training data set. Now the next one, prediction. Predicting the binary classification model. That means what? Logistic regression. Then how to predict? So there is a predict method. So this method predict whether the model just we have been built is giving correct output or not. Before going for testing, first of all we have to predict it. Now what we are giving? We have to give testing data. Already we divided the total data set. Incidence data set is divided into 2 parts. Training data set for training the model and testing data set for testing the model. Now I am giving this one. Once you run this command, we got what? 4 values are there. Once you go back and verify, so already I told you clearly, above 40 years. The people who have above 40 years, they can apply or have insurance. Once you look all these 4 points here, 44, yes, above 40, 45 above 40, all these 4 points are above 40 years. So definitely they have insurance. Yes, S, S and S. Right. Now there is another method is there. Yes. Once you apply here, see here. Above 50%, it is 94%. Means what? Definitely they'll get insurance. Right. 33%, 03, 96, 05, 94 probability. High probability is there, right? High probability. That means what? Definitely these all 4 data points will, belongs to what? S category. All these what comes under S category. Now, if you consider one, another set of data points, just we have to rerun this one. Once rerun, you can take, different changes. 2 I am taking here 2. Let us run this code and run the train data. Yes, these are what the different training set of data points. Now, verify testing data. Yes, so testing data here, increased, right? 44, 41, 93, 29. Yes. So definitely, once you test the model, the 16th index, it's not comes under S category. It should comes under, which one? No category. 29, 33, 23. These 3 comes under what? 4. These 3 values comes under what? No category, and this 38 also. So 4 no's and remaining S category. Now download the model, create object and fit train the model with a new training set. Once you predict, yes, we cannot find like this. Just remove this one and now train it. Yes. See, I showed clearly. No, 4 no's are available, right? Yes. 3 no's and remaining all are what? S. So that means what? The model is correcting. The model is working perfectly as per binary classification. Yes, I told you clearly binary classification. It classifies the outputs either of the classes. Now here we are using which classes here? Only 2 classes are there. The class names are what? S or no, right? Yes, that means what? This model is working perfectly, right? Now if you can give different values here, no, we have to give what? Multiple values, no problem. I'm giving here test. Yes, right. So out of those many things, 3 persons comes under node category. Remaining, data points comes under S category. So like this binary classification works. So by this, I'm going to end this session. Thank you, listening and spending your attention. Right? Yeah. Just now we have, we have seen that the building the, binary classification model. Right? Now once again, I'll revise the concept here, the classification technique here. The classification is a technique for determining which class the dependent belongs to the either of the classes, right? So as we have seen in the model, right, the classification means categorizing data. Yes, it categorizes the data and form groups, right? So in binary classification, only 2 classes will be there, but whereas in multi-class classification, more than 2 classes, more than 2 classes. So in a data set, the independent variables or features play a vital role in classifying our data. Yes. So we have seen that, incident data set, we applied, we built a model. So there, age and incidence. So these two data points played very vital role in order to find out, the classification. So already we have seen, the binary classification, right? Yes or no. So by using this yes or no category, we have built the model by using logistic regression. Same thing, we can take a data set, we can categorize all the data point of people that comes under male or female category. Now, take a different data set and divide the data set into two categories, male and female. Same thing, if you have males, the whatever males we are receiving daily, we can categorize all those received mails into spam or not spam category. Same thing, I have only two categories are there, cat and dog. Right, two categories are there. So cat and dog. So whatever image we are giving, this model can predict whether this image belongs to cat or dog. So like we can classify, we can take the different data sets. In next session, we'll discuss about what multi-class classification. So in multi-class classification, which contains what multiple classes, but whereas in binary class classification, which contains only two classes, like we have seen, we have built the model yes or no, male female, like that. But in multi-class classification, more than two classes. And coming to the types of classification, the first one is the logistic regression, second one k nearest neighbor classification, and third one support vector machine learning classification, the fourth one naive Bayes classification. So already we have seen the binary classification and multi-class classification. So according to the binary classification, which form a line, a curve between independent as well as dependent variables. So it's called regression, but it performs classification. Yes, even though the name indicates regression, but it performs classification based on a threshold value. So we have built the model which contains two classes, right? Now we have this picture is showing class A and class B. We built S or no category. S or no. So all these whatever data points we plotted here, these data points are categorized into two classes. 1 or 0, male or female, class A and class B, like that. Now once you compare logistic regression and linear regression, so linear regression which draws a straight line, but in logistic regression which draw a sigmoid S-shaped curve. Now, this logistic regression is used for prediction of output which is binary. Yes. So as per binary classification, the output is either 0 or 1. Binary means what? Only 2. So two classes will be there. The whatever output we are getting, that output will be classified into two categories. Example, the credit card company can build a model, binary classification model. So that model, once you give the customer data, the customer's purchasing, bill paying history, once you give it to the binary classification model of credit card company, that model will categorize all the customers into two categories, issuing and not issuing category. Now here, if you want to build the logistic regression, we have seen already, first of all, we have to perform, linear regression. We have to perform linear regression on data set after getting that output, so by using sigmoid activation function, we can categorize output into discrete values. The whatever output we got it, that output is in continuous in nature. That output will be converted into categorical value or discrete value by using what sigmoid activation function. Now threshold value is very important. So based on this threshold value, we can categorize the output. So the threshold value is what? 0.5. The output which is above 0.5 comes under one category. That output below the 0.5 comes under another category. So like we can categorize the output into either of the classes. So 0 class or 1 class or S class or no class or male class or female class, etc. So this is the formula for linear regression. So whatever output we are getting, that output will be applied to the sigmoid function. So this is what logistic sigmoid function, right? Now 1 by 1 plus e power minus y. Now what is y here? The y means what here? Y is equal to what? mx plus c. mx plus c. So already I told very clearly, right? First of all, we have to perform linear regression. Now this linear regression output will be applied to the sigmoid activation function. It will give us the probability value. The value will be between 0 and 1. So based on this one, we can categorize the output. Yes, probability of y and probability of y. So already we have built the model based on incident data sets, right? Yes. So by this, I'm concluding today's session. Tomorrow we'll discuss about what multi-class classification by using logistic regression. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.